Now, this is yet another question on titration for WAEC 2026 Chemistry Practical. Question number 1, possible questions on question number 1, which is the titration experiment. Okay, uh, we have I've done a video, uh, 2 video or 3 videos on titration generally, titration problems. So if you have not watched those ones, you can do well to watch them. Now, this particular one is very, very important. Okay, very, very, very important. Okay, because this particular one has been tested before in WAEC school candidates. It has been tested before, where the acid uh, is not mentioned, the basicity of the acid is not mentioned, the uh, anion present in the acid is not mentioned. So, but the base, sodium hydroxide, was mentioned. Okay, so the only information we have about the acid is its concentration. And for the base, we have the number of moles in the acid, the number of moles in the base per 250 cm³ of solution. So we have to titrate A against either 20 cm³ or 25 cm³ portion of B using phenolphthalein as indicator. Okay, you see that the previous examples with the previous questions we did, it was methyl already as indicator. Okay, because for titration of a strong acid and a strong base, all indicators are suitable. Methyl orange is suitable, phenolphthalein is suitable, methyl red or litmus, they are all suitable. They can be used to perform this experiment. Okay, because of the fact that the pH change or pH range for strong acid, strong base titration is wide. Okay, now this titration, this is a table for the titration. Okay, we are assuming that the titration has been done, and this is the table. You should, when you are presenting your table, as I've said in the previous video, you must ensure that the units are stated and you have a consistent decimal places. Okay, and your Titer value for the computation of your average volume of acid used must be concordant. So it must be concordant, and the range of difference between the Titer value, the volume of acid used, must not be more than plus or minus 0.20. Very, very important. And also, your Titer value, you should try to be very accurate in your experiment, such that your Titer value must not be more than that of your teacher by more than or less than that of your teacher by 0.15, so that you can get the maximum mark. Okay, so typically a typical table used to carry about 8 marks, while your average Titer value will carry about 2 marks. Okay, so when you are picking the values for your calculation of your average volume of acid used, you must ensure that, okay, you pick values that are very, very close, as I said, plus or minus 0.20 from one another. Okay, it is suitable to pick just 2 titration values, volume of acid used, or you can pick 3 and divide by 3, or you can pick 2 and divide by 2. So each of those ones you pick carries 4 marks each. 4 marks, 4 marks. Okay, so you must make sure you pick the Titer value that's recognized as being concordant. So in this, we are assuming that the titration has been done and the table is being presented. And in this titration, we are assuming it is we are using 25 cm³ of volume of pipette, which means the volume of base is 25 cm³. All right. So what is now the average volume of acid used has been calculated, and it is 12.0. Okay, and as I've said in the previous video, you can pick 2 values, or you can just pick the 3 values and use it to calculate your average volume of acid used. So to calculate the average volume of acid used here, our average titer is, we can pick just 12.20 plus 12.20 divided by 2, or you could pick the 3 and divide by 3. Okay, but 2 will be marked. Okay, so we have, it is 12.20, and you put your unit, CMQ. You must always put your unit. If you don't put your unit, you are going to lose about 1 mark. If you don't put units, you're going to lose 1 mark. And as I said, you don't write in pencil. In the marking scheme, it is stated that students that write with pencil should lose 2 marks once. Let's say you write any part of your solution with pencil and you submit it like that, you are going to lose 2 marks. So please pay attention to that. Don't write with pencil in any way, at any time. Okay, if you write with pencil, you have to clean it, or after tracing with pen, you have to clean the pencil. Okay, so you are going to lose 2 marks if you write anywhere in your answer booklet in pencil. Now, as I've said earlier, this question is quite different in the sense that the basicity of the acid is not mentioned. Okay, so let's look at what are the calculations we are to calculate here. So don't forget, this table and the average titer carries 10 marks. Now the calculation usually carry roughly 11 marks to 13 marks. Okay, so B part, from your result and the information provided above, calculate. So we are assuming now we have done the titration. So the first instruction is amount of acid in the average titer. Amount. Remember that the word amount means moles. Okay, so amount of acid in the average titer means calculate the in other words, you can say calculate the number of moles of acid in the average titer. Okay, good. So in this case, it is going to be difficult for you to write a balanced equation. It will be difficult for you to write a balanced equation of, we have HYX, okay, plus sodium hydroxide to give what? You cannot predict the product because the basicity of the acid is not mentioned. So you cannot predict to say it's good. Is it NaX or Na2X or Na3X? You don't know. So the question is not a question of a regular question of CAVA over CBV is equals to Na over Nb. In fact, you don't need that formula in this particular context, for the fact that you don't know the number of moles or the basicity of the acid. So how do we approach this? So the first question is amount of acid in the average titer. What is the average titer? The average titer now is our VA, and it has been obtained to be 12.20 cm3, right? And we want to calculate the amount. If you look, the question also gives us the concentration of the acid. Okay, the concentration of the acid was given. Let's go back to the question and see that concentration of the acid was given to be 0.102. So we use 0.102 moles per dm cube. Moles per dm cube is the same thing as molar. So the concentration in mole per dm cube is Ca, also called molar concentration or called molarity of the acid. So from here, the number of mole of the acid, Na, is Ca multiplied by Va. Concentration of the acid multiplied by the volume of the acid. So the concentration of the acid is 0.102, and the volume of the acid is 12.20. So it's in cm cube. So we have to convert to dm cube by dividing by 1000. So we have 12.20 divided by 1000 as our volume. And if you compute this, you're going to get 0.00124444 moles. Okay, if you want to approximate this to 3 significant figure, you have 0.00124 as your amount of acid that is present. Now, amount of base that is present in 25 cm cube. No, we are not using 20 in this case. We are using 25. Okay, so meaning our VB is 25 cm cube. So what is our CB? What is our CB? We go back to the question. Was CB specified in the question? Let's go there. In the question, it was specified that we have 0.025 moles per 250 cm cube. So from here we can calculate molar concentration. So you can quickly calculate your CB. So CB is not given, it can be calculated. Our CB is number of moles of CB in the volume given over volume of solution. Volume of solution. So number of mole of CB given in the question is 0.025 in 250. So we have 0.025 in 250, which is 0.250. Okay, and if you divide this, you are going to get 0.1 moles. We're going to get 0.1 moles. Yes, I think we're going to get 0.1 moles. Okay, as the okay, let's see. Let's mark this 3 times 1, 2, 3. So yes, 25 over 250, which is going to be 0.1 moles. That's correct. Then we move on to calculate our number of mole of acid now. So number of mole of acid now is going to be number of mole of base, CbVb. So we have calculated Cb to be 0.1 and our Vb to be is given to be 25 over 1000. Okay, and if you compute this, you should get 0. You should get 0.0025. 0.00250 should be our number of moles. 0.0025. That will be the number of moles of B. Now, the next part of the question is calculate the mole ratio of acid to base. Mole ratio of acid to base, that is the number of moles of A or over the number of moles of B. Okay. Now, we have already calculated the number of moles of A to be 0.00125 and number 124 rather, and number of moles of B is 0.00250, 3 significant figure. Okay, so computing this, you see that this ratio is around 1:2. Because if you compute this now, if you punch calculator, you're going to get around 0.5, close to approximately 0.5, meaning that the mole ratio of acid to base is 1:2. So the correct answer to this question is number of mole of A ratio number of mole of B is 1:2, or you just say 1/2. Good. Now, after this, now that you know that the mole ratio is 1:2, what does that tell you? Now the question is asking you to write a balanced equation for this reaction, for the fact that you now know the number of the mole ratio. So the mole ratio will also be the stoichiometric ratio in the equation will also be 1:2. So we have HYX reacting with sodium hydroxide, and we have been told that it is 1:2, so we put 1:2. Then definitely from here now we know that our base is going to be Na2X, right? This is the anion in the acid is X, so Na2X plus water, because a neutralization reaction will always produce an acid and water. So also we'll see that the reaction will not be balanced. Okay, the reaction is not balanced, but for the fact that we have Na2X, we can quickly predict that what we are going to have here is going to be 2 moles of water. What we are going to have here is going to be 2 moles of water. Okay, so since it is 1:2, and for this to form, it means this X must have a charge of 2 minus. Okay, if it has a charge of 2 minus, you can predict that means the X here will still be 2 minus. Then from here you will see that your Y will actually be 2. Your Y will actually be what? Will be 2. So the question says, the next question here is state the basicity of the acid. Okay, from what I just explained now. So this acid is reacting with 2 moles of sodium hydroxide. So it means for sure this will definitely be uh, an acid with basicity of 2, for the fact that the acid is reacting with what? Is reacting 2 moles of the base. Okay, so it means the basicity of the acid is equal to 2. So meaning that Y is actually equal to what? Equal to 2. So the acid is H2X. H2X. Okay, plus sodium hydroxide is what produces this. Now, in nowhere was the anion present mentioned. The anion present was not mentioned anywhere. So you have to be very, very careful, especially for the fact that you know the reagent. If you mention SO4 anywhere in this question, then you mention H2SO4 in anywhere in this question, the examiner will know that you have cheated and you can be penalized. Penalized for it. That is, you have been informed about the specimen before um, the the exam. Okay, so be very, very careful. So basicity of the acid here is 2, which shows that the acid is what? Is dibasic. So that is that. So this is another very possible, this is a solution to another very possible question that can come this year. As I've said, this question has come before. This exact question pattern has come before. Exactly the way I've presented it like this. It has come before. Only that the concentration presented in that particular year is not exactly as this. It's not exactly as this. It's different. So it has been tailored to suit the specimen that was provided so for this year. So um sorry, this is for the previous question. So try as much as possible to ensure that you practice all these questions and check the part 1, part 2, part 3 of this video. Okay, from experience, the questions will not pass these 4 questions that we have looked at. So do well by reviewing them. Use your own Titer value to solve them by yourself so that you can be sure you understand every part of the questions. So also don't forget to leave a like the video so that it can also help the channel to grow, and share the videos with your colleagues so that they can also benefit and everybody can smile in the examination hall without necessarily having to cheat. So thank you very much. See you. So okay, before that, I want to mention something also. The qualitative analysis video also is being produced, so watch out for that part. So but subscribe so that once you subscribe and hit the notification bell, you will be alerted once the those video has been uploaded. So thank you for watching.